Hi everyone and welcome to today's Chemistry Daily Booster. This is number 5 in our Paper 2 series. Do note that this is an advanced information listed topic and it is for both the foundation and higher tier chemistry students, because what we're going to be looking at are some of those key practicals that are listed on the advanced information. First thing we're going to consider then are flame colours. Now, the place you're probably most familiar with these different flame colours as a result of a chemical reaction is in fireworks, because as fireworks burn or explode, then the metal ions that are present within their structure become vaporised, they absorb energy, causing electrons to jump to higher electron shells, and then as those excited electrons drop back down to their normal electron shell, they release light energy in the form of obviously a certain colour based on the amount of energy being transferred. So when it comes to actually trying to identify an unknown metal, we can carry out our own flame test in the lab. Now, flame tests in the lab are just carried out in a very simple way. We're going to use a nichrome wire loop. And the first thing we've got to do is make sure there's no other substances on it. So we've got to clean it by dipping it in concentrated hydrochloric acid, and then we hold it in a roaring Bunsen flame, and we repeat that process until the flame doesn't change colour, because that tells us there's nothing else on it. Once we've got our nichrome wire loop nice and clean, what we do is we dip it into our test powder or our test solution, and then we hold it in the roaring flame and watch for the colour, because it is the colour that we generate that's going to allow us to identify what metal is present. So nichrome wire loop, dipped in concentrated hydrochloric acid and then in a Bunsen flame, repeated until the colour doesn't change to make sure there's no other contamination on there to start with. Then we dip it into our test powder or our test solution, hold it into the roaring Bunsen flame and note down what colour it goes. These are the 5 colours you've got to memorise. Lithium goes red, sodium yellow, potassium lilac. Please remember the word lilac, not other versions of purple. Lilac is specific and necessary. Calcium is orange red, and copper green blue in colour. So I'd suggest again, get your flashcards out, stick the kind of flame test metal colour of lithium on one side, red on the other. Have that as a little pack. Just test yourself over and over again until you can recite these really easily. What we will find is that there is a potential source of error in these if there's any contamination. So if there's any bits of powder or solution that have fallen into the Bunsen burner, then you could get some different colours there. If you haven't cleaned your loop properly, there could be some other chemicals present that would give you a different colour. So we need to know these 5 because they're the only ones they're going to expect you to know, but you also need to be mindful of the fact there could be some errors if there's contamination. In terms of safety, obviously we are using a Bunsen burner, so talk about things like there's a risk of burns, and obviously to avoid that you're going to make sure the Bunsen burner is well away from the edge, that you're not going to touch the nichrome wire loop when it's hot, anything like that. Remember, just standing up is not going to be enough to get you marks for a safety aspect. I don't think there's anything they could really ask in terms of improvements to this experiment. It's most likely to be sources of error and the colours. A second test that we can do to identify one of our chemicals that could be present in an unknown solution are the hydroxide precipitate tests. When we look at the group 1 hydroxides, these are soluble in water, whereas most other metal hydroxides are insoluble. And this is why when we carry out our hydroxide precipitate test, we're going to be using sodium hydroxide solution. Now, sodium hydroxide solution is a very common chemical, you will have used this. And what we're going to do is get a test tube, we're going to add a small amount, about 1 centimetre cubed or so, of our unknown solution, and then we add about 1 centimetre cubed of our sodium hydroxide solution. What you're going to see is a little precipitate, which is an insoluble solid, forming in the test tube when you do this. The colour of that precipitate is going to tell us what metal ion is present. Here's the list that we need to learn for these. Another 5. Iron 2 will be green, iron 3 orange brown, copper 2 blue, calcium white, zinc white. So what we see here is we actually have 2 that both give us a white precipitate. What we need to do to identify whether we've got calcium or zinc is we add an excess of our sodium hydroxide. When we do that, if it's zinc hydroxide, then what happens is it dissolves and we get a colourless solution. If it's calcium hydroxide, it will not dissolve no matter how much sodium hydroxide you add to it. So again, make sure you've learnt these colours, make sure you know how to work out whether it's zinc or calcium hydroxide present, and beware that they could ask us to write ionic equations based on this. We've got the full equation at the top there, and remember, in a net ionic equation, we're ignoring any spectator ions, so any that just stay unchanged from one side to the other. So if we have a little look at this, what we can see, we've got copper ions, sulfate ions, sodium ions, hydroxide ions on the left, and then on the right we've got copper ions, hydroxide ions, sodium ions, sulfate ions. So what are we looking at here? Look at the state symbols, because at that point you're possibly thinking, well, everything's an ion, it doesn't change, they're all just spectators. However, look at your state symbols. We start off with 2 aqueous solutions and we're going to make a solid. So we know the copper hydroxide in this example is key. So that is changing because we're changing from aqueous solution to a solid. However, the sodium and the sulfate we can ignore. So we don't need to worry about sodium, don't need to worry about sulfate, cross them off on each side, and that just leaves us with our copper ions, hydroxide ion on the left, and then our copper hydroxide, the solid, on the right. We know hydroxide ions are OH-. Copper will only be Cu2+ in the examples they give you, so you can very easily write the next ionic equation there. Don't forget that if there are some questions there that you're sitting there thinking, I'm not 100% certain on these tests, you can use the video on the main channel in the C4 playlist just to review them in a bit more detail. You can also obviously go back through your revision guides, your classwork notes, just to make sure you're really confident in these, because we know they're coming up, and therefore be sure of those colours if nothing else. I would also recommend having a look at some of the past exam papers just to get a bit of a feel for the kind of questions that come up here. And then, of course, as always, don't forget to join us again tomorrow for our next daily booster.